go through the process of how to translate an organic name like this one into the full structure and the condensed structure. So the first thing, when you are given an organic molecule's name, the first thing is to identify the parent chain. That would be things found on table P and table Q. So when I take a look here, I see F. So that is my prefix for the parent chain. So this is what I would look up on table P. And when I go to table P, F means N equals 2. So I am going to put 2 carbons right there. Now I take a look at the ane part, and that tells me the bonding in the parent chain, and it's single. So they are only linked together with one bond. So the first thing is draw your parent chain with the correct bonding in it. Now place other things that are on this structure that are also in the name. So I take a look and I see bromo. So that is something that is from table R. So I can go to my table R, okay, and I look for bromo. So I see bromo here, and this is what I need to add to the parent chain. So this means I have to add a BR to it. But now, when I take another look at this, okay, it says dibromo. So that is the number of BRs on that I have to add to the parent chain. And then lastly, these numbers here tell me the location of the BRs on the parent chain. So once when you see those locations, immediately go to your structure, and I always build these left to right. So this would be carbon 1 and this is carbon 2. So there is one bromine on carbon 1. So I'm going to put it here. And then there is the second, the di means there's another bromine. It's on carbon 2. I like to put one up and I like to put one down. It just visually helps me see it a little bit better. Okay, make sure you're showing your bonds there. Now, I have put everything that is in this organic molecule's name on the structure, but carbons don't have their bond fulfillment. So once when you've put everything in the name in the structure, now you do your bond fulfillments with hydrogens. So now you go back through. So this carbon has 2 bonds, it needs 2 more, and it gets those from the hydrogens. Same thing with carbon 2. It has 2 bonds, it needs 2 more bonds, so we do the bond fulfillment with hydrogen. So this is what the full-blown structure would look like. So here we go. We're going to do the condensed structure. So carbon. So carbon 1, okay, it has 2 hydrogens. So it always goes in the order of carbon. And if there are any hydrogens attached to that carbon, you put those in second. And then if there is something else attached to that carbon, it comes next in the structure. So the condensed would be CH2Br. So everything is now showing for carbon 1. Now I move on to carbon 2. Carbon 2 also has 2 hydrogens, and it has 1 bromine. So quick reminder that when you have your parent chain, so I'm just going to underline these, so that's a parent chain carbon and that's a parent chain carbon. Whatever is sandwiched between a parent chain carbon and the next parent chain carbon, so whatever's to the right of it, that is what gets attached, or it belongs. It belongs. So these 2 hydrogens and this bromine belong to that carbon that comes before it. And then these next 2 hydrogens belong to this carbon, and this bromine. So if you are given the structure and you have to draw it out. Okay, so here we go. Here is another example. So here is my table P prefix. Okay, so that is my table P prefix, and that means meth means N equals 1. So that means I have 1 carbon, and it's ane because there's no other carbon for it to form a double or triple bond to it. Now, when I look at this name, okay, I see chloro. So that is something that is from table R. So if I go to table R, I look at functional groups and I find chloro. So that means CLs have to be added to the parent chain. So chloro means Cl. Now I also notice that it says tri. So that tells me the number of chlorine. So tri means that we have to add 3 Cls to the PC. So here we go. So I got carbon 1. I'm going to add the 3 Cls to it. Each of the Cls have their single bond. Carbon needs 4. We've put everything in the name in the structure, and now we finalize the structure with hydrogens to fulfill carbon's bond need. So the condensed formula, you start off with your carbon. Immediately after the carbon would come any hydrogens attached to it, so it has 1 hydrogen, and then anything else besides hydrogen would go next. So that would be Cl3. Last example here. So the name looks really long here. So when I look at this whole thing, I see the prefix pent. So that is my table P prefix. And when I find pent, that means N equals 5. So I need to draw 5 carbons. And I notice that in the structure, or it ends in ane, so that means there are only single bonds in the PC. So I'm just going to put 1 dash between each of the carbons. Now I see number locations. So right away in my structure, I'm just going to number my carbons 1 to 5. And when I'm drawing, I go left to right just to be systematic. So carbon 1, 2, 3, 4, and 5. So when I take a look at this, so the first thing that I notice is chloro. Chloro means I have to add Cl's. I see that there's a di, so that means I have to put 2 of them on there, and here is their location. So the location is 1, 1. So both of those chloros are placed on carbon number 1. Check, that is done. Then I keep moving. I notice the term fluoro. Fluoro means I have to add F to the parent chain. I notice that there is a di there. So that tells me that I need 2 fluoros, and now this is their location. One of the fluoros is on carbon 2, and the other fluoro is on carbon 3. This is a pretty complicated structure. And as I keep reading, we're not done yet. I also see I see ido. So I see ido, and if you're not sure, go and find the term ido. That means I need to add an I to the structure. And it tells me the location. So I go and I find carbon 3 and I add the iodine there. So now in this structure, I have added everything to the I've put everything in the molecule that the name is talking about. And then now I need to do bond fulfillment. Any carbon that does not have 4 bonds, we fulfill it with hydrogens. So carbon 1, it has 3 bonds, so it needs 1 hydrogen. Carbon 2 has 3 bonds, so it also needs 1 hydrogen. Carbon 3 already has 4 bonds, no hydrogens. Carbon 4 only has 2 bonds, so we have to add 2 hydrogens to get to the 4 bond fulfillment. And carbon 5 only has 1 bond, so we have to add 3 hydrogens to it so it gets its 4 bond fulfillment. The molecular or the condensed structural formula for this would be we have carbon 1, hydrogens that are attached to it are immediately put, so it has 1 hydrogen, but then it has the 2 chlorines. Carbon 2, okay, it has 1 hydrogen and a fluorine. Carbon 3, no hydrogens, 2 different halides, so alpha order. Fluoro F comes before I and Ido in the alphabet, so I put CF. I. Carbon 4 has 2 hydrogens attached to it, and carbon 5 has 3 hydrogens attached to it. So there is the condensed formula.